In this video, we're going to be looking at the 5 ways that we can use to test whether or not a figure is a parallelogram. But before we do, first and foremost, it's super important that we know that a parallelogram is a quadrilateral. It is a 4-sided figure. All right, so once we're past that important piece of information, here are the 4 things that you can use to test whether or not a figure is a parallelogram. The first one is the definition. And the definition of a parallelogram states that the opposite sides of the parallelogram have to be, you guessed it, parallel. So opposite sides are parallel, which means if you see a figure, parallel. If you see a figure and the figure is showing you these arrows, so we have arrows here saying that those opposite sides are parallel, and then you see another set of arrows showing you that these opposite sides are parallel, then automatically you will know that the figure is in fact a parallelogram. All right, so now there are actually 4 more methods to test whether or not a figure is a parallelogram. You really only have to have one of these methods to work in order for you to be absolutely sure. All right, so that's the first one. Sorry about that. All right, that's the first one. And the second one states that if both pairs of opposite sides are congruent, then the quadrilateral is a parallelogram. So opposite sides are congruent. So again, let's draw this out. If our parallelogram looks like this, as long as we know that both opposite sides, so that side and that side, as well as this side and this side, as long as they are congruent, then we know for sure that the figure we're looking at is in fact a parallelogram. So that's the second way. Another way we can tell whether or not a figure is a parallelogram, let's use blue, is if both pairs of opposite angles are congruent, then the quadrilateral is a parallelogram. So let's draw that out. Let's write that first. Opposite angles are congruent. So if our parallelogram looks like this, as long as we are absolutely sure that that is equal to that, so our opposite angles there, and this here is equal to this, as long as we know that both pairs of opposite angles are congruent, then we know for sure that we are looking at a parallelogram. All right, so there are 2 more ways that we can be sure that we're looking at a parallelogram. All right, so let's turn the page because I ran out of space. Okay, so the 4th way that we can know that we are looking at a parallelogram is if our diagonals are bisecting each other. So let's write that down first and then let's look at the example. All right, so if our figure looked like this, and then we have a diagonal here and a diagonal here, if we see for sure that that is being, well, if that line is being cut in half, so that is equal to that, and this here is equal to this, then we can see that our diagonals are in fact bisecting each other. And once our diagonals bisect each other, you know that you are looking at a parallelogram. Okay, so the last condition that you can use to test whether or not a figure or a quadrilateral is a parallelogram is to see if one pair, at least one pair, is both parallel and congruent. So let's draw this out. So let's write it first, of course. All right, so one pair of opposite sides, of course. OPP for opposite. Are both parallel and congruent. All right, so if you see a parallelogram and you only have information on one pair of sides, you know that they're congruent to each other, and you also know that they're parallel to each other, If you know that that one pair of sides are both congruent and parallel, then you know that you're looking at a parallelogram. So as far as these 5 methods to test whether or not something is a parallelogram, you don't have to test all of them. You only have to test one. If one is true, then all will be true. So you have to just make sure that one is true, and then you'll know you're looking at a parallelogram. All right, so let's look at one quick example and then justify quickly why it is in fact a parallelogram. Okay, so here we're being asked to determine whether or not this quadrilateral is a parallelogram. And we're off to a really good start because we already know that since this is 14 and that's 14, those lines FG, those line segments, FG and HI or IH have to be congruent to each other. So that is a good start. From one of our conditions, we know that if we can also show that those lines are parallel, then we'll know that this is a parallelogram. Can we see if this is parallel or not? Well, those 2 angles are consecutive interior angles. If you recall the fact that I can extend this here, and let's draw it out here so you can have a better look. Remember this guy right here? So these 2 angles are consecutive interior angles. If they are in fact parallel, then these 2 angles would be supplementary. And 80 and 100 shows that they are in fact supplementary. So because these 2 angles here, this angle and this angle, are supplementary to each other, it's showing us that these 2 lines have to be parallel. So now that we know that these 2 lines are congruent and they are parallel, then we also know that this must be a parallelogram. All right, that's it.